Hello students, welcome to the second lecture of binomial distribution. Now we'll see the first question of today's class. A die is thrown 6 times. If getting an even number is a success, find the probability of number 1 at least one success, number 2 less than or equal to 3 success, next 4 success. I hope everyone understand the question. A die is thrown 6 times. So it is nothing but when I'm throwing a die, one die, what are the possible outcomes? Tell me. There are 6 possible outcomes. Yes or no? A die containing 6 faces. One, 2, 3, 4, 5, 6. Right? So the possible outcomes are 1, 2, 3, 4, 5 and 6. See, these are the possible outcomes when throwing a die 6 times. If getting an even number is a success, so what are the even numbers in this possible outcomes? 2, 4, 6. Yes, right? So getting even number is success. So chances are 2, 4 and 6. Then what is the probability of P here? What is the probability of P? Favorable event by total number of events. So how many favorable events are having? Mean getting even number 3. Yes. So 3 by 6. So we can write it as 1 by 2. I hope everyone is clear. Then if P is 1 by 2, then what will be the value of Q? It is also 1 by 2. Okay, right. And I discussed in the previous class, when he talking about the kind, P value, Q value, he won't discuss in the question. If you're talking about the other experiment, apart from kind, so how many times I'm throwing a die? 6 times. So it is nothing but n equal to 6. Now coming to the first solution. What is asking to find here? At least one success. At least one success. I may get 2 success. I may get 3 success. I may get 4 success. I may get 5 success. I may get 6 success. Yes or no? He asking in the question at least one success. What is at most? I'm throwing it 6 times, right? So at most is 6 times I'll get a success. Then how do you denote here probability? P of x greater than or equal to 1. Okay, P of x greater than or equal to 1, at least one success, right? So what are the values of x here? 1, 2, 3, 4, 5 and 6. Yes, so I can denote it as here P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3 plus P of x equal to 4. Okay, right. Then at x equal to 1, what is the binomial distribution? To solving the solution, we require binomial distribution formula, right? So P of x equal to ncx p power x q to the power n minus x is a formula. Yes. So I'm writing the binomial distribution at x equal to 1 now. Okay. Right. 6c1 P is nothing but 1 by 2. 1 by 2 to the power of 1 into 1 by 2 to the power of n minus x 6 minus 1. Okay, plus, so which is nothing but I written a binomial distribution at x equal to 1. Similarly, at x equal to 2, what is the binomial distribution? 6c2 1 by 2 to the power of 2, 1 by 2 to the power of 6 minus 2 plus plus 6 at x equal to 3 also will write a binomial distribution. 6c3 1 by 2 to the power of 3 into 1 by 2 to the power of 6 minus 3 plus at x equal to 4 I'm going to writing a binomial distribution. So 6c4 1 by 2 to the power of 4 into 1 by 2 to the power of 6 minus 4. See, this is the way we are writing at x greater than or equal to 1. Okay, I mean at every x I written a binomial distribution. Okay, right. So now it will become 6c1 1 by 2 to the power of 1 into 1 by 2 to the power of 5 plus 6c2 1 by 2 to the power of 2 into 1 by 2 to the power of 4 plus 6c3 1 by 2 to the power of 3 and 1 by 2 to the power of 6 minus 3 is 3 plus 6c4 1 by 2 to the power of 4 and into 1 by 2 to the power of 6 minus 4 is 2, right? So now 0.9844. Okay, this is the probability of at least one success less than or equal to 3 success. How can I denote here? Less than or equal to 3 success means P of x less than or equal to 3. Can I denote it? Yes. So x less than or equal to 3 means what are the values of x here? What are the values of x here? 0, 1, 2 and 3, right? Because less than or equal to 3. So P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3. Now at every x value I am finding the binomial distribution and I will add those all. So 6c0 because x equal to 0, right? 6c0 1 by 2 to the power of 0 1 by 2 to the power of 6 minus 0. This is the binomial distribution at x equal to 0 plus at x equal to 1 6c1 1 by 2 to the power of 1 and 1 by 2 to the power of 6 minus 1 plus 6c2 1 by 2 to the power of 2 1 by 2 to the power of 6 minus 2 plus 6c3 1 by 2 to the power of 3 1 by 2 to the power of 6 minus 3. Okay, now 0.6562. See, this is the probability at x less than or equal to 3. So now coming to the third answer, 4 success. 4 success means is x equal to 1 2 3 4 0 1 2 3 4 or only 4. Yes, only 4 because 4 success. P of x equal to 4 it is equal to, then at x equal to 4 I'm writing binomial distribution 6c4 1 by 2 to the power of 4 and 1 by 2 to the power of 6 minus 4. Then what is the result of this probability by substituting in the calci? Tell me. 0.2344. Okay, at x equal to 4, this is the probability I'm getting. I think everyone is clear to you. Okay, in this question we'll see the one more question, that is read this fourth question. 6 dice are thrown 729 times. How many times do you expect accept at least 3 dice to show a 5 or 6? 6 dice are thrown 729 times. How many times do you accept at least 3 dice to show 5 or 6? Okay, so in this question, I'm having a 6 dice, but those dice I'm throwing 729 times. So what will be the value of n here? Is 729 or 6? 6 dice 729 I'm throwing. Then here n is nothing but 6. Okay, right. Now what will be the value of p? Tell me. What are the possible outcomes? 1, 2, 3, 4, 5, 6. These are the possible outcomes. Yes or no? In this possible outcomes, P is expressing as 5 or 6. P is expressing 5 or 6. So can I say 2 by 6 is nothing but the value of P? Yes. So it is nothing but 1 by 3 is the value of P. Then Q is equal to 1 minus P. It implies 1 minus 1 by 3. Then it will become 2 by 3 is a value of Q. Right. N over P over Q over. Yes. And now what is asking in the question? How many times do you expect at least 3 dice to show 5 or 6? Can I denote P of x greater than or equal to 3? Because at least 3 dice to show some to show 5 or 6. I may get 4 dice or 5 or 6. I may get 5 or 6 in 5 dice. I may get 5 or 6 in 6 dice. Yes, right. So now what is the binomial distribution formula? Binomial distribution PD equal to NCX P power X Q power N minus X. This is the formula of binomial distribution. Okay, right. So now P of X greater than or equal to 3, it is equal to P of X equal to 3 plus P of X equal to 4 plus P of X equal to 5 plus P of X equal to 6. Okay, right. So at x equal to 3, what is the binomial distribution? And how can I write? 6c3 1 by 3 to the power of 3 into q 2 by 3 to the power of 6 minus 3. Yes, plus at x equal to 4, 6c4 1 by 3 to the power of 4 into 2 by 3 to the power of 6 minus 4. Now at x equal to 5, 6c5 1 by 2 3 to the power of 5, 2 by 3 to the power of 6 minus 5 plus at x equal to 6, 6c6 1 by 3 to the power of 6 into 2 by 3 to the power of 6 minus 6. Okay, this is the probability. Now 233 by 729. Okay, This is the probability of getting at least 3 dice to show 5 or 6. Okay, right. Observe the question properly. 6 dice are thrown 729 times. So it is nothing but whatever the probability I found now, can I say one time probability? Yes, this is the probability of getting only once to getting 5 or 6 out of greater than at least 3. Okay, right. But I'm throwing those 6 dice 729 times, right? Then can I say multiply this probability, getting probability, with 729? Yes, we have to multiply that probability with 729. Then we'll get a required probability of 5 or 6 by throwing 6 dice 729 times. Okay, right. Getting 5 or 6 in 729 times is 729 into 233 by 729. Then by cancelling 729, then 233 is a solution. I mean 233 times we are getting 5 or 6. Okay,